Hello, it seems that we are live. Thank you for coming in. Yeah, obviously there are no any viewers yet on LinkedIn because the premiere is on LinkedIn. To those of you who are watching on YouTube, that's only a recording. If you want to attend the original one, the premium, no, not premium, the premiere, you have to go to LinkedIn. I will drop a link to my profile in the description of the video. So next time you will find me quickly. I want to say that last time I received negative feedback to the background music, that the description was that there is a metronome sound in the music, but I didn't aware of it, and when listening from speakers I didn't catch that metronome sound. But when I put my headphones on and put the volume significantly higher, I realized that there is a metronome sound, so I changed the music. I downloaded 3 non-licensed tracks. This currently playing is some chill game music. I don't know if it will work. The previous music was the Brain FM, which was kind of stimulating. It was non-licensed as well because there were advertisements inside of the video, inside of the track, not the video, obviously. These 3 new tracks are unlicensed, but not of so high quality. We'll see. Obviously, we don't need background music, but sometimes I am silent for a while, and a completely silent video is annoying. Back to work. Today, I want to work on component placement of the LM3645 board, which is quad boost LED driver. There are 4 outputs, 4 channels. The total current of the boost driver is 2 amps. And as datasheet says, there is the maximum current per channel is 500 milliamps, which is probably the limitation. So not the total current. It means that it's 1.5 amps on one channel, and the rest shares the resting 500 milliamps. This is not the case. The case is that 500 milliamps per channel is the limit. Anyway, we want to design this, something like this, a demo semaphore light, traffic lights. Last time I calculated that 11 LEDs can be a suitable number of LEDs per cycle, per light element. Why 11? I calculated that 8 will be on the perimeter of the circle, like in the octagonal shape, and 3 will be filling the inner space of the circle. I don't know if it will work or not. We can add or remove any LED we want. I will use the standard THT LEDs with 3 mm in diameter because I found a reasonable stock in my magazine. So I will use them because I think there is no better usage for them than this demo board. So 3 channels will be green, red, and yellow. Yeah, there should be orange, but I don't have orange, and I beg your pardon, I will not buy the orange LEDs when I have 20 plus yellows. So that's the situation. And the fourth channel will be a green LED, a single LED like status. I will try to program like blinking or flashing or status LED. So I think we can start. Let me check comments. No comments yet. I hope there will come. Yeah. This is 39th or 40th, I think, live stream, and I act like a complete beginner. There is a field of on your screen in the bottom right corner where new comments appear. There is no such a comment, so no comments. So it means to me that I don't need to check on the StreamYard window. I just can check the the streaming, let's say, streamed screen. So let's make a quick check. Annotation, okay, we have completely annotated schematic. Let's go ERC, electric rule check. If there are some 0, 0, so we did a good job last time. No ERC findings. Frankly, there is nothing like complex in the schematic. This is I2C drivers, so ESD diodes, pull-up resistors for I2C, some decoupling capacitors for input voltage of the driver, inductor for the boost. There is unpopulated snubber components as described and recommended in the datasheet. I think the snubber components are requested. I can imagine that the EMC with this driver, when like really pushing the limit of the boost converter, can be non-zero, to say it let's say correctly. So anyway, two other decoupling capacitors for the local output of the I think inner LDO, for outputs for the LEDs. These are the traffic light LEDs, and this is the status LED. This is a system connector with I2C enable pin and input voltage along with the ground. Here is the thermistor sensing the temperature of the IC and probably the board. We will see where we manage to place this NTC, the thermistor. Last time, if you didn't watch, I spent significant amount of time of thinking out loud how to fan out this really fine pitch BGA. The pitch of this BGA is 0.35 millimeter, which is for my American viewers, which is exactly 13.8 mils. This is the pitch of the IC, and at first, when I created the footprint, I was really lost because I didn't believe that I would manage to fan out the BGA package. But when I started studying the datasheet with the diagram of ports, and when I saw the actual ports, I realized that the pinout of this BGA is so well designed that literally only one pad is difficult to fan out. And this is, frankly, I think three of them, the strobe 1, strobe 2, strobe 1, as you can see, I will zoom in because on your screen the picture is small. Yeah, I could open the footprint editor, but yeah, I'm not so smart. So strobe 1, strobe 2, and temp 2. These are the inner pads. Yeah, you can see that V out will be fan out by the track, switch as well, D2 as well, D3 as well. So only 3 pads. And I verified in the datasheet that neither of these 3 pads, strobe 1, strobe 2, and temp 2, is necessary to connect. So I can leave them floating, and by configuration of the IC, of course, there will be some issues when I will program the IC, because at first I had to like disable the functionality of these 3 pads, at least, especially for temp 2, which when left floating could make some false errors of the temperature sensing or temperature measurement. So yeah, temp 2 should be configured at first, and the strobe 1, strobe 2, I think I will not use them. The boost driver is dedicated or designed to, like, you can imagine the controller of your cell phone LED flashlight on the bottom side of your cell phone, and the strobe inputs are dedicated to control the flash. Yeah, the fast, I would say, transient light effect of the boost driver. So that's not our case. We are designing a traffic light demo board. We don't need strobes. So yeah, that was the last time recapitulation, and now we can start. I can see that we have a comment. Let me make it bigger. Hello, Abdullah. Thank you. Top 5 things I recommend to learn. Yeah, you can start with LEDs. LED can look like, or at first, an LED looks like a simple device. Yeah, what can be complex with it. Two electrodes, 2 pads, 2 wires, some forward voltage drop. Yeah, nothing strange. Right? No. LEDs can be tricky. You have to be careful about the reverse voltage, which is very low. For instance, 5 volts can be a typical reverse voltage, or slightly bigger, but you can't expect like 60 volts or 100 volts. So when you drive the LED circuits, you have to be careful about reverse voltage, because reverse voltage can damage your LED component easily. Then you have to be careful about forward voltage when setting the current, when using the shunt resistor for setting currents. So you have to calculate rather carefully the LED forward current. There are characteristics in the datasheet. So start with the datasheet. As I said, reverse voltage, forward, where is my camera? Forward voltage. Then you are talking about the LED driving circuits. Yeah, you can use a simple BJT or MOSFET driver. The simplest one is with the common, let me place one with common source electrode. It can be designed like this. Here is the LED. Here would be some resistor. Let me place this one and some input voltage here. Yeah, this is the input voltage. Here can be the driving signal. Yeah, like the DRV. Oh, I immediately deleted. Okay, this is the simplest switch for LEDs. I don't recommend driving directly any LED from the MCU port or any logic device. Why? Simply said, to protect the MCU port or any logic device port. The LED can be harmful, can be deadly when damaged, and then your sensitive input logic devices can be damaged easily. So I recommend using similar switches like this one. When you want to use more complex devices, as I'm working on, definitely check datasheet, read datasheet, study datasheet, use LLM or AI for it, notebook LM, ChatGPT, Gemini, anything. If you are lost in the datasheet, last time I used ChatGPT for checking if I have to place the stroke 1, stroke 2, and temp 2 pads. I can see that even the TOR/TX is not used. I don't know. No, this is not the case of the inner pads as I mentioned earlier. So back to the Abdullah question: reverse voltage, forward voltage. It means forward voltage is like connection between forward current and forward voltage. There is a characteristics, voltage ampere characteristics in the datasheet. Then drivers, I recommend simple NMOS drivers or BJT drivers with NPN transistor, very similar to the circuit I created here. So you can replace this NMOS with BJT, but you have to place some base resistor to limit the base current of the BJT. So I can say that the NMOS driver is easier to use. To be completely precise, you have to place a gate resistor here of a, let's say, 100K or something. I am editing to avoid confusing. Why is that? When your MCU or logic device port is floating, then this resistor set the gate source voltage drop to literally 0. So simply said, it keeps the LED driver off in office state when there is no driving signal of a high level. Yeah, we can go deeper and deeper with the NMOSes. You can check the V gate source threshold. You have to use a suitable NMOS, but yeah, that would be only about the LED drivers. So yeah, I don't know if I can name 5 things, but I think at least 4 I already listed. Thank you, and I'm going to I'm going to place the components. As usually, I will start with the component layout with the split screen mode. Yeah, now I am updating the PCB from the schematic. No errors, no warnings. This is what we want. Now we have all components here near the 0, 0. Yeah, like here near the 0, 0 coordinate. What I'm going to do is to disable the silk screen, then disable values, and that's it. No problem. Ask anything, anytime, and I will do my best to respond as quickly as possible. So I will start with a top left corner, because this is when my brain starts reading anything from the top left corner, and with grid 0.5 millimeter. So let's say here will be our like initial shape of the PCB. And now I'm thinking out loud that when we are designing the semaphore, the traffic light, even the PCB can be in the shape of the semaphore lights. So yeah, Definitely. So what I'm going to do, I will limit the size of the top edge to, let's say, 50 millimeters, maybe less. Now we have 67, which is too much. 38, 40 is like this. 40 to 80, yeah, something like this. I don't want to create a huge PCB, but yeah, something like, I don't know, we have 11 LEDs of 3 millimeter. I think a thumbnail size of the light can be fine, which is about 20 millimeters. So circle in diameter of 20 millimeters can be used. Yeah, it means that we have to start with the circles because it will drive our shape of our PCB and as well size of the PCB. So I will start with a simple circle put in the user.drawings layer, and then as on common traffic light device semaphore, we have the red LEDs on the top. So now I am selecting all red LEDs in the schematic, and KiCad automatically selects all red LEDs or all particular components from here. So we have 11 components, 11 LEDs to be placed here. Yeah, as you can see, now the LEDs are like distributed evenly, and we can say that their, I don't know, area fills the circle of 20 millimeters in diameter rather well. So I will start with the 20 millimeters, and there will be a trick. I will make the window bigger to allow you to see everything. I will start with the first LED. It doesn't matter, but I want to use the first one. And yeah, I don't like that we don't have a consecutive range of the designators. This will make some issues, but I will not spend much time here. Okay, so I will place here this one. D2 is the first one, yes. And I will place it here, which is off the grid because KiCad lost the ability to place the center of the component on the grid. And whatever grid you are using, thank you, designers of KiCad, you messed it up. Now I am going to use the create array from selection, and circular array is the thing. Center position will be center of the circle. So this is our center point. We have to fill full circle with 8 LEDs. And we don't want to rotate items because the LED is circular, so we don't need to mess with the position. Let's call it, and we will see what happens. Yeah, we evenly distributed LEDs along the perimeter of the circle. But as you can see, the KiCad created or copied the LEDs, like they put new LEDs. It put new LEDs into the schematic. So my task will be to manually reassign numbers of these LEDs, because the create from selection doesn't have the ability to rename or to keep designators of the initial of the first component. Anyway, it works rather well, but I think 3 LEDs in the center will be not enough, or will be. We will check. Now we can use a similar trick. The center point of the circle stays the same, but now we have only 3. That rather work, but I don't know why this LED is slightly higher, but I can make the corrections manually, which is something we should do anyway. Yeah, this one should be aligned with this one, so position of this one is 100.5, so X will be 100.5, and here as well. Okay, that can work. Let's see how it looks in the 3D view. I think it looks fine, but here is a gap. We don't need a gap. We don't want a gap there. So yeah, here is a significant gap. Now we can rotate only by 90 degrees, which is not what we want. So I'm checking the position of the LED. Why the hell are some of the LEDs red and some of the LEDs not? Aha, the selected LED. Okay, I have 3D model which contains only a red LED. Okay. I'm calm now. Yeah, it makes me rethinking the entire thing. I think 3 is not a correct number. No, it's not enough. 1 in the center is not enough. We can get closer. Let me change the perimeter LEDs by putting the LED closer to the center, like this, to edge the shape of the LED with the, I don't know, pre-designed circle. Again, 8 LEDs. How it looks? It looks better. It looks better, but I think we can go even one. There can be 1, 2, 3, 4. You know what? I will go even closer to the center with this LED. Yes, I think this can be, 9 LEDs. 9 LEDs it is. So instead of 11, we will have 9 of them only, of each of them. So when I update No, this is not what I wanted. Yeah, do you know what happened? The new LEDs were removed because they have representation in the schematic. So now I have to assign the reference designators as I mentioned earlier. So second is D5, the third is D8, D11, D14, D17, D20, D23, and the central is D26. Okay, now we have assigned the red LEDs in the first circle. Now I can update the schematic. Multiple footprints. Yeah, definitely all these LEDs are extra. Now we have our red LED circle. Now we have to inspire with this. I don't want to use a super complex thing. I will draw a circle similar to the shape of the light element in here, and yes, of course, but the create from array put a new components that are not in the schematic. So these newly added components have the unassigned component designator. So you either have to update the schematic or the PCB, and I chose the PCB. Yeah, here is the circle, and when taking the circle as a scale, we can see that about a third of the diameter of the LEDs is in between the LEDs, the light elements. So we have 20, so 1/3 is about 7, 6.66. Am I right? Yes. So this is to be copied. But differently. I have to be in the in the 0.5 millimeter grid. I have to put my cursor to the center of any LED, but the element of the center you are using must be at the grid, on the grid. It is. And now I can copy, and now I'm on the grid. And we said that 6.66 is, yeah, our spot. So you can see that I have glued the components on my cursor. Now I'm pressing space, and the auxiliary in the bottom of the screen, the auxiliary scale is zeroed, and now I'm moving 6 millimeters, 6.5 or 7. 6.5 is fine. So these will be our orange or LED or yellow LEDs. And again, we have to place our yellow ones and 6.5 as well. So now we have evenly placed components of our LED, of our traffic lights. What I have to do is to reassign. It means edit the designators. So the central, these are the yellows. This is D3, Yeah, I can edit only, or it's to edit the reference designator is enough, because when I update the PCB from the schematic, the KiCad will use the reference designator as the anchor, and then to reassign all the values and order codes and yeah, other things. So only the designators. D9 is the third one, D12, D15, D18, it means that the module is 3, D21, D24, yes, and D27 in the middle, in the center. Now, the green ones, D1, D4, D1, D4, again, the module is 3, but I am checking each designator separately because I don't want to make a mistake. We don't have time for that. What was the last? D13, so D16. D19 is this one. D22 and the central D25. Okay. Now I can remove all the LEDs, the resting LEDs, because we don't need them. What we need is the signature of the connector. So now we have placed all LEDs. Let me update the PCB from the schematic. Okay. And yeah, there is one LED. What's this? Let me say what this. This is the status LED. This will be somewhere near the driver. Okay. Now we have to check the schematic, and we have I can see 4 groups. We have ESD LEDs and the system connector. So this is group number 1. We have mounting holes. Do we need mounting holes here? Yeah, we need. I don't know where we place them, but yeah, we need them. And we have the controller. Now without the ESD components. So this is our third group, and this one, this little thing, is the NTC. Okay. So I will place the component below the green circle. Yeah, somewhere here. Here will be all the components. On the right side, on the left side, I don't know, will be the system connector, and the mounting holes will be like distributed evenly around. So let's place nicely in the center. Let's place the BGA, the IC, but what I'm doing now, I'm checking the recommended layout. Ah, you can't see it because I'm sorry. We need to be here. This is the layout example. Obviously, the bottom edge here will be our top edge because our LEDs are above. There is one more comment. Can we swap the existing components with newly added components? Yeah, sure. You can swap them, but I didn't want to move them from their positions because I spent significant amount of time of placing them. So instead of moving them, of like pushing them around on the PCB, I changed the reference designator. Yeah, probably I don't understand what do you mean. There are two ways. By the create from array, I was created a newly components that are not represented on the schematic. So I had to deal with the newly created components. And what I did was that I changed the reference designator of the newly created components with the ones from the schematic. The newly created components had the unassigned new designators that their representation of on the schematic was 0. There were no on the schematic. So I think the most straightforward way was as I did, to edit the designators with the existing ones, because the newly created was like an extra ones. Yeah. Anyway. So where is the edge with the LEDs? Here. No. The switch node is probably here. Yes, this is the switch node. So we can place the inductor like here. The input voltage, the coupling capacitors are these two. You can see that even the tiny IC with comparison to the 0.06, I think, or what is this? No, I placed 0.402, and you can see that the size of the cartridge of this capacitor is almost the same as the IC, and you can see what they used in the left example. And this one, what's that? I don't know. And they recommended 10 microfarads. So what else is on the schematic? The output capacitors near the C1, okay. And the snubber components that must be close to the switch node. The output are near the near here. This is 10 micro and this is 10 micro as well. So I will place them over here. We have the snubber. And thermistor. This is the snubber components. Yeah, big S. I don't know what. How do you like the music anyway? I think it's not as uplifting as the previous one, but there is no metronome in it, and it's unlicensed completely. I downloaded it from 𝗞𝗶𝗖𝗱. I don't know if now I breach some legal license thing, but they say that the songs were, the tracks were unlicensed, so I downloaded 3 of them. No registration, no tool, just download from the website. So I believe, I don't know. What's this? The I2C, okay. This can be near the system connector. What do we have? Oh, we have we have a rather strange component placement. Let's check the channels. The status can be switched with green because yeah, it would work better, and the red with the yellow. So status with green on the IC, status with green and yellow with red. Okay. I was using the vertical mirroring by pressing Z on the keyboard. Okay, now we can place the status LED like on the left side of the IC to create some balance in universe, because otherwise the component layout is, no, I don't know. I love the symmetry and balance, but this is nothing of it. This is what it is. We have NTC. Where is our NTC? I didn't place there. Didn't place it there yet. Haven't placed it there yet. C. Not the correct position. What does say the... They are funny at Texas Instruments this time. Just the VIA, yeah, just the VIA. I don't mention the VIA sync pads for these components, the pads. As I mentioned, if you remember, strobe 1, strobe 2, and temp 1. Ah. Do I have a mistake in the temp 1 is on the edge? Temp 1 is in the center. Let's check it quickly. My temp 1 is on the edge, E3. Temp 1, E3. I have the correct assignment. D3 is temp 2. And they, in the section of the layout example, have E3 of temp 2. There is a mistake. If you want, you can send an email to Texas Instruments reporting the mistake. I will do that. I did multiple times, and I'm not sure if they even reply. But I love you, Texas Instruments, anyway. I still love you. Nobody is perfect. So yeah, I'm in the grid of 0.5 millimeters, and I have to manually edit the coordinates because the components are not placed on grid. What the hell do you developers of KiCad think? I don't understand. $14 from the center, I'm sorry, and 14.5. So this is the symmetric. So it means 28 is the pitch, let's say. So 28. And 28 will be definitely closer. Something like this. Let's place the system connector. Now I see. Hey, there is a lovely area on the bottom. I think I again forgot to place the. No, I didn't. Okay. Many devices. Logo is there. Okay, we are safe. We are safe, but we have to count with the logo as well. Here will be the logo, and here will be the system connector. That will be lovely. Well, I don't command it. I move it slightly off the grid. Aha, I understand. I was trying to place the system connector on the same coordinate as the LED in the center, but it doesn't work. Why? Because the central point of the system connector of the header is in the center of the point of the pin 1, so that is 5.08 millimeter far from the center of the LED. I don't want to solve this equation now. This will be our ESD diodes. I highly recommend to place them in the same direction, despite the fact that these LEDs, these diodes are like symmetrical, bidirectional. Doesn't matter because the pick and place machine like to place the components with the same rotation to avoid like twisting around. I don't mean that it's something that can harm the machine, but it's something that can save your time. Of course, we won't place the components of this evaluation board on the machine, but I think when you create a good habit and keep with this habit, it's beneficial to all your design work. Is our network working? Because I noticed that there were some. Okay, probably we are online still. The last two components are the I2C pull-ups and I can see that because of the logo position at the bottom, I will place these components here. But let me say something. When there are 0402 components, all the capacitors are 0402. Why not to place 0402 as well, to keep a balance? Okay, I changed. Update PCB from schematic. Ping. I will try this position and then we will see. Okay, let's create some miracles. We are 57 minutes in the show, and I want to take a tiny little break, like the service break. If you like what I'm doing, check on 𝗏𝗏𝗀 my new, not new, this one is from the last year, KiCad for beginners, and this one, KiCad for makers, is from this year. This is brand new tutorial course on 𝗏𝗏𝗀. Check them all if you like what I'm doing. You will learn much more in these courses than in the design streams. Let me take the break. I will be back in a minute. I am back. Let's get back to the PCB. As I said, edge cuts. It means we are working on the shape of the PCB. This is center of the light, and for instance, 30 millimeters. Oh, 30 millimeters. It means 15 radius. Isn't it too much? Maybe 13. Yeah. Let's do this. .5 is the verified distance from the center of the mounting hole. Now I am using a trick of creating a rectangular, then shape modification fillet 4.5. Now I can remove this. This is my auxiliary center. Oh, I need to be here. Yes, 4.5, here. No, it doesn't work because I'm too close. Anyway, I will, yeah, I will help myself. No problem. Okay, we have position from here is 3.5 millimeters from here, so we will move the corners and two mounting holes minus 3.5. That's lovely, as well as these two, but on the opposite side, opposite direction. Now we have thick, and here. Okay, I'm not commenting the shape. I love the shape. I don't know if I don't know if I can send this to manufacturing, but I think at least the, you know what, I'm not commanding it. This is our traffic light. Okay, that's not my intention to create something like this. It happens. It happens, and today it happened. Yeah. What do you say? I love it. Tricks. Routing. Zero 0.3, 0.5. I will try to keep with the default via sizes of 0.6, 0.3. The clearance, I don't know. Let's check the 𝗲𝗱, who will be our manufacturer. The issue is that two-layer, two-sided PCBs are not so. Yeah. There is minimal pad size of 200 micros, which is our case, but I think the spacing is too too high, so we need to use the 4-layer one, the 4-layer stack up, because of the design rules. Okay, so the minimal clearance of the 4-layer ANIC boards is 0. I will set it because for fanning out the BGA I need it. Let's try. Oh, here. Okay. Yeah. Of course, I will use the polygons. Now I'm just projecting where the signals will be routed. I think, yeah, this is. I don't know what's better for the corner pets. Do you know? Can you give me a piece of advice? What do you prefer for the corner pets? I mean, to fan out it to the left or to the bottom? What they have here? Yeah, yeah, something like I have. Yeah, okay. The ground is okay. I will use the tracks instead of the polygon near the pads, because for my manufacturing, my experience is that when there is a polygon near the pads, it can cause the short, like the shorts on the pads. But where there is there are two tracks with the mask in between, it avoids creating shorts. But I don't know. Okay. Okay, so let's create a polygon for the inductor L1 pet 2. I will keep the default setup because, as you know, when KiCad, when you edit the existing polygon, KiCad will remember the numbers. Otherwise, you have to re-edit them repeatedly. So I will keep the default ones for this polygon, and then I will edit the shape. So now I'm editing the shape. We want solid, some priority, clearance 0.2, fillet of 0.5. Let's start with it. Okay, but this is not what we want. We want definitely a bigger. Yeah, the trick is to place another corner near the corner to avoid creating the fillet, because this here I don't want to. You are such a troublemaker. Okay, that looks good. We need to place, we have to connect the snubber. But yeah, I will connect it with the track only to make the soldering easier. the ground polygon. The same strategy. Something like this. .5 is too much for this particular polygon. That can be fine. And we need the input voltage polygon. Yeah, let me use this trick, like to project the shape of the polygon. It will be something like this here, and from here that can be only a track here, and these components will be connected just by wire. Okay, so this will be our polygon, like from here. I have to repair the corners. The corner near the left edge of the pad, because there are multiple points placed as well here. The snapping to graphics make my job okay. Nothing easier than removing a few. I thought that there is a mistake, but there wasn't. Okay, it looks good. We can remove the auxiliary track, but not the entire track. I will place a thinner track here, because I want easier soldering to avoid thumbstone effect. So enable SDA. I'm just trying if this routing will work. This 38, 37, this must be swapped. Yeah, this is the same as Dinesh Kumar asked. Yeah, of course I can swap them, but when the components are placed, it's much easier to edit the reference designators because it's quicker. This is diode for SDA. Yeah, the diode for SDA is 38. Okay, SDA is 38. This is 38. Yeah. No, this is not. What happens? 37. Not SDA. Oh, yeah. This is my punishment of renaming the designators, but it's a legit. What the hell? These 37. Maybe there is a mistake in the schematic. Of course it is. Of course it is. Yeah, the wire must go there. So instead of placing it, I am getting back, and now when the schematic is corrected, yes, I can update the PCB. So it wasn't a punishment, it was my mistake. And did you see the DRC didn't find anything? I spent some time arguing with guys that hate LLMs or AI or something. I published a post mentioning that I'm using ChatGPT. I enrolled ChatGPT into my development process, and a lot of guys said that no, this is wrong. We have DRC for years. We don't need the checkers. We don't need hardware reviews. We don't need LLMs. Is bullshit. It's everything. You could see DRC didn't find anything. These guys are not designers. So we have to fan out our LED output. But I will start with the LEDs. It looks like a drunken sailor, but I will show you a trick. I hope it will work. Select the entire area. In the selection, put or press the mouse right button, filter selected items, uncheck all items, check only tracks. Okay, now you have selected tracks. Now switch the grid to 0.5 because we place the LEDs in 0.5 grid. Now in the center of the center LED, press Control C or Command C and Command V, like and let me place it. Yeah, this is the snap to graphics. Here. But the tracks are now red, yes. So select, oh, no, it reassigned to yellow. Okay, that's good. And we have to do the same. Get back to the 0.5 grid and place it for green. Go to the find page and place the track green. Okay. I want 1 millimeter, so board setup, predefined 1 millimeter. I will use the track to, let's say, to route the track from the segments. And the polygon will be in the last mile, like here. Okay. Another polygon, green, solid, priority, no, something bigger than 0. Something like this. Yeah, there is a clearance. This is fine. The other one is yellow. I recommend playing with the symmetry. It always pays off. Yeah, but I need some space to connect the third polygon. So this is nicely placed, but I have to put it slightly far from the, I see, somewhere here. Okay. This is the red. I think the red will be slightly on the edge. But we will see what the clearance will do. Yeah, this is higher priority zone. This is number 3. And this is number 1. So the number 1 got thinner. I don't know if it's correct, because this is a small bottleneck. Yeah, but I will use this because the connection of the red is thinner, so we don't want to. Okay, I will use this. The ground will be on the entire bottom layer, not only all inner and bottom layer will be assigned to the reference plane. Again, we don't need the 4-layer stack up here. We need the finer design rules, and design rules are more suitable to this design for 4-layer 1.6 millimeter PCB. The two-sided is like not so fine. So we are not driven by, or our decision to use 4-layer stack-up was not driven by the signal integrity, power integrity, anything. It was driven by the design rules. Okay, it seems that we have almost all components connected. Now I want to use like 1 millimeter track from here, from the inductor. Something like this. like the funnel shape polygon, something like this, and this will go here. I didn't want to go through the ESD diode because it would cause some manufacturing issues. Definitely a thumbstone or something we don't want to deal with. Okay, what do we have? We don't want this. We can want this, but it's user drawing. Okay, let's put it into the silk screen, slightly thinner. How would it look? Can be fine, even thicker. That's nice. I like it. I like this circle so much. When the silk screen layer is edited, I will call the DRC. Why not now? Many reference designators incorrectly placed caused false warnings, or let's say unwanted warnings. I want to deal with the real issues only, not with some artificial things. So I always edit the silk screen layer. This is nice. I love it. I love it. I have to push the status LED more far from the IC to be just below the LED here. It's a detail, but and now I am editing all the resting reference designators in silk screen layer to be 0.7 in width and 0.7 in height and 0.1 in thickness. So this is the NTC snubber components. Here is decoupling capacitor. We have to mark the pet number 1 carefully. Okay. We don't need J1. But what we need is to place the header closer to the PCB edge. Oh, you know what? No, we will keep it. We will keep it because we need lovely small labels. Smaller. Oh, it's too wide. I will use normal. Yeah, that can work. The board name and status. For status, I will use this status. LM 3645. 2 millimeters, let's say. Yeah, it can work. Date code. Somewhere here. Let's go to the RC. 12 warnings. Oh, yeah, this is the board setup constraint of the minimal size of the label, which is 0.8, but we have 0.7. Record the RC. One warning, unconnected end. Okay, this is some more piece of track inside of the track. 0, 0. Okay, how it looks. This is our traffic light semaphore demo board. Okay, we are done. No more comments, no more questions. So, thank you for watching and see you next time.